Hey, it's Rob. Welcome back to our KYJ series. This is our alphabet series, and today is the letter D. So join us. We're going to do 5 Ds, 5 words beginning with D, and this is knowing your jargon. So here's our first D. It's digestion. So digestion is a complex process. We think we know what digestion is. You think you know what digestion is, but let's just recap. Digestion is the process of taking in a macronutrient, taking in food, protein, carbohydrates, lipids, fats, and all of the micronutrients that are sort of locked up inside that food that we eat, and then breaking it down through a number of stages. Firstly, mechanically, we squelch it and we chemically dissolve it in an acid bath in our stomach. Pepsin starts to break down protein, and then a number of enzymes are released, usually from the pancreas and other parts of the GI. And those enzymes interact with the food that we're eating, and what they're doing is they're breaking down those macronutrients, carbohydrates, fats, and proteins into their small enough components so that they can be absorbed through this small intestine. So if we think about carbohydrates like starches, rice, potatoes, pasta, bread, all the way through to the sugars, they're broken down into ultimately monosaccharides to make them small enough so that we can absorb them. And the monosaccharides are your glucose, your fructose, and your galactose. Absorbing those into, ultimately they go to the liver to start with, and the liver kind of processes all of that stuff. Proteins are no different. They're broken down with pancreatic proteases and different chemicals like pepsin in the stomach that starts to break down those proteins into those 20 or so amino acids that we've got that make up the building blocks of protein. Remember, protein molecules are too big to absorb straight up. So from the food, it's got to be broken down into those amino acids or amines. And lipids, of course, lipids are made up of triglycerides, so a glycerol molecule and fatty acids. And so we have to break those lipids down into small enough fat globules. So lipase, we use intestinal lipase, and we also use lipases that are made from the pancreas, mixed with bile. And we're going to make those fats small enough to absorb and again be taken off to the liver. That process of breaking it down and absorbing it, we simply call that digestion, and that's our first D word. So the next D is a pharmaceutical term. It's digoxin. Digoxin is a fairly old cardiac drug. It's an interesting drug because it's one that increases the force of contraction, and we refer to that as inotropy, the force of cardiac contraction, but it also decreases heart rate. So it slows down heart rate as a cardiac decelerant, but it's an increase in inotropy drug. So it's a cardiac inotrope. Positive inotrope, negative chronotrope is how we'd refer to it. Important considerations when having a patient on digoxin is to make sure that we keep an eye periodically on their digoxin levels. It's renally excreted, and so if somebody's got renal failure, so then doses of digoxin can stack up, and when somebody becomes digitalis toxic, it can cause all sorts of funky looking arrhythmias like accelerated junctional rhythms and badness like that. Digoxin comes from nature, actually. It comes from the foxglove, and if you're in a colder part of the world, places like New Zealand or southern Australia, you more than likely are going to have foxglove, beautiful flowers of foxglove growing in your yard. Really toxic. Don't eat them. Not recommended. 1 Google star review. A DVT, that's our third term. Our third term is a DVT, a deep vein thrombosis. And the interesting thing about DVTs is that they're growing in your veins of usually your lower leg, although people can have DVTs in other parts of their body, like arms, but usually in the lower legs. And these thromboses grow inside the larger deep veins of the lower leg. And as they start to develop, they cause a decrease in blood flow. The decrease in blood flow is often not felt or often not experienced. It's insidious, it's long-term, it's chronic. The big danger, of course, is that one day that deep vein thrombosis, a little piece of that clot, that thrombosed clot, can break off. And when it breaks off, it can float up through the venous network. And as it comes back to the right heart, and it travels through the right heart and then into the lungs, it's somewhat unobstructed. Remember, from the veins of your legs, which are very, very, very narrow, those vessels just get bigger and bigger and bigger until you get all the way back to the heart, and then they get smaller and smaller and smaller in the lungs down to the pulmonary vasculature. And for this reason, a person who has a DVT that breaks off and embolizes, that often gets stuck in the lungs, and that's what we would call a pulmonary embolism. DVT. Risk factors for DVT: being sedentary, so having surgery, just having surgery, any kind of trauma or surgery. Cancer is a big risk factor. Smoking is absolutely a risk factor. Pregnancy or hormone replacement therapy, being on the oral contraceptive pill. These are all risk factors. And long haul flights or long haul train trips where you're just not getting up and doing a lot of movement. Big train trip or a flight from, hours and hours and hours sitting in the same chair without moving around. So, DVTs, if you're at risk, often you can take either a thinner, some sort of a blood thinner, or some people wear DVT anti-thromboembolism stockings, kind of like those TED stockings. They're anti-thrombotic stockings. Compression socks. Yeah, DVTs. Not recommended. Okay, so our fourth D word is dromatropy. Dromatropy. Now, you've probably heard of inotropy, which is the force of a cardiac contraction. You've heard of chronotropy, which is how fast the cardiac contraction takes place. But dromatropy is a concept that refers to how fast an electrical message can travel along a nerve impulse. So when we contract our heart, what we're going to do is we're going to send an impulse from the SA node out across the internodal pathways, down to the AV node, through the bundle of His and the His-Purkinje junction, down the bundle branches into the Purkinje fibres in the bottom of the ventricle. And if you can imagine, that impulse has to travel all of that distance. And if I could start a clock from the time that impulse first started at the beginning of the P wave, all the way through to the time that contraction has happened in the ventricle at the end of the QRS complex, that time is referred to as the dromatropic time. So some medications will speed up dromatropy, and some medications will slow down dromatropy, the speed at which that electrical impulse passes down through that myocardium. Adrenaline's a good example. It increases dromatropy, the speed of the electrical impulse. And our last one is D for dendrite. Dendrite literally comes from the Latin, and it means branches of a tree, dendritic, dendrils. So the dendrites, they're the kind of little whiskers at the beginning of a nerve cell. So if you think of a nerve cell sends an electrical impulse down its body and then a chemical impulse that leaves the end feet of the nerve cell and transfers across the synapse and goes into that synaptic cleft and diffuses across the synapse between the nerve cell and the muscle cell or the gland or whatever other cell that nerve's going to stimulate. Once that neurotransmitter has arrived on the surface of that cell to reach its receptors, in nerve cells, their receptors are located on the little spindly, feathery, branch-like structures on the top of that nerve cell body, and they're referred to as dendrites. Dendritic means like a branch-like. So, how'd you go with the 5 Ds? Hope you learned something. If not, come back tomorrow. We're going to do E, the letter E. This is our Knowing Your Jargon KYJ series. Hope it was helpful. See you next time.